Hey everyone, Ethan here, back with another video for you guys, another episode of Blips this time, and here we are going to be explaining hard disk drives, or HDDs as a lot of you know them. Now, hard disk drives, or HDDs as I'll call them from now on, are a storage medium for PCs. As many of you know, it's how information is stored on your PC in bits, ones and zeros. They are primarily used in desktop PCs today. Laptops don't use them as much, except for the thicker ones. A lot of them have converted to SSDs, which I'll be explaining in another video. Hard drives are not really that related to SSDs, although they have benefited from the advancements in SSDs, which I will get to in a bit. Now, hard drives are, like I said, commonly used in desktops and also servers as a huge environment for them. They are cheaper when it comes to the amount of storage that you get for the money, but they're not as fast as SSDs. Now, they've been the main storage medium for a very long time when it comes to PCs, and just recently, over the last, I'd say 4 or 5 years, has it started to kind of change depending on what your workload is. You know, a lot of us still use hard drives, but some of us don't. They're cheaper, more budget-oriented computers and stuff use them, but in the end, they store information, and the way they store this information is in ones and zeros, bits, as hopefully many of you understand what a bit is, but if you don't, that's how a computer stores information, as a 1 or a 0, an off or on as an example. That's how all computers, how code actually functions in a computer, but that in detail is for another video. Now, hard drives are generally enclosed in metal and or plastic, usually a metal shroud of some sort with some plastic parts on it and whatnot. Inside that is the important part, obviously. And what you have in there is you actually have discs or platters. That's why they call them hard disks, is they're platters, they're actual physical discs. They're not, also not like a CD or something like that where they're semi-flexible. They call them hard because they are hard. Now, the disc platters in there tends to be made of either glass or aluminum, which you may be wondering, how does that work when it comes to storing information on that? How do you store ones and zeros on that? More on that in a moment. Now, this disk is then spun inside the hard drive. As many of you can hear when a hard drive is running, you hear the motor and stuff spin up. There's a physical motor that is actually spinning the hard drive platter in there at generally pretty high speeds. It varies usually between 5,400 and 7,200 RPM, but sometimes there's some other odd ones in there like 10,000 or 12,000 RPM, as well as like 5,600 RPM, and they can dynamically oftentimes change the speeds that they are spinning at. Now, there's actually a needle that reads and writes to that disk by applying a magnetic force or reading from a magnetic force, and that is generally connected to some sort of a printed circuit board with a microprocessor to control everything in there and send all the information over to the PC, generally through a SATA or SAS cable, which I'll have other videos describing specific cables, but as of course this is on hard drives. Now, the important part, as you can imagine, is those platters as well as the needle that is reading and writing, which it actually didn't used to be a needle. There used to be a ring that read and write to the platters, but that ended up not being as efficient. They couldn't have as small of a grain size, which is the physical size of each bit on the drive. That's 1 grain, as you could call it, and so that you can have the grain density of platters can actually be different, and you couldn't get as small of grain sizes using a ring technology, so they use a needle instead in order to read and write from hard drives. As I said, those platters are commonly made of glass and aluminum, which may surprise a lot of you. A lot of people assume, if you understand the basics of hard drives, that they're made of some kind of magnetic material, like something that is ferrous rather than a non-ferrous material, but they're not actually. So the platters tend to be glass or aluminum. Glass is more common in laptops, which actually may sound weird. Why would you use glass in something that's more likely to be dropped? But they're actually more shock tolerant. Glass is able to flex more than aluminum and go back to its original shape without bending, breaking, etc. So the glass platters tend to be used in regular laptop hard drives, whereas desktop hard drives tend to be aluminum. As far as I understand, it's because it's cheaper, and there doesn't seem to be much more reasoning behind that. Glass was actually developed by Toshiba in 2005 is when they first started using it, as far as I understand. They probably had it in some prototypes and stuff like that, but it was widely distributed in 2005 for laptops for greater shock tolerance. On top of this glass, during the manufacturing process, on top of this platter, this glass or aluminum platter, there is actually a metallic coating that is usually not particularly magnetic, but it's a metallic coating enough to allow data to be read and written to it. So the metallic coating is applied at a very, very thin layer to it through a process called sputtering. I'm not going to get into the details of how that works, but that is how they apply this coating. Now, oftentimes the coating is also referred to as a film because of how thin it is. You know, it's not a thick coating by any means. So, yeah, you know, the terms can be used interchangeably here, but it is oftentimes called a film. And that film in particular, that coating, is optimized for the grain size of the platter as well as what needles you're using and stuff like that. So that film and the chemical composition of that film can change, but it is a metallic film. On top of the film, they actually dip the platters in a carbon-based protective coating that is approximately 1 nanometer thick. So very, very, very thin coating, but it's enough to protect it from, you know, very, very minor stuff. Obviously, if you take apart a hard drive and you start touching it and stuff, that's going to ruin it. You know, they're very, very, very tolerant, or very, very intolerant to imperfections, little bumps, scratches, things like that. You don't want to mess with them. That's why they're fully enclosed. But there is a actual small protective coating that is applied to them in the end process of manufacturing the platters. And then on top of that, there's also a nanometer thick lubricant, which is what helps allow the needle to fly over the hard drive, because it quite literally floats on a very small pocket of generally air, you know, oxygen, or sometimes also helium is commonly used, but it floats on top of the platter, and they have that lubricant there just to help with that kind of process there. Less friction, the better. They're spinning pretty fast. The less friction you have, including the less friction with the air molecules in there, the better, because the motor doesn't have to work as hard to spin it at the same speeds. At the very end of the manufacturing process for these platters, they are buffed and scanned for defects. They are buffed to an incredibly smooth surface. If any of you have taken apart a hard drive before, you know that the platters themselves are like a mirror. They're incredibly smooth. They're, you know, just very interesting, and they're buffed to perfection, quite literally, as good as possible, and then again scanned for defects just to see if, you know, anything's wrong with them. They use a needle that can detect defects. So like I said, there's a metallic coating on the platter itself, and that metallic coating can retain a specific magnetic polarity in a specific area. That is, you know, a grain as an example, and the grain size varies. This is why hard drives actually vary when it comes to the amount of storage they have, not just by the number of platters that you can physically fit in a hard drive, because they will commonly stack many of these platters in a single drive, 6, 7. I mean, you know, they can stack quite a few in there. But also the grain size, or the amount of actual areal density, or the amount of data that can be stored in a specific area on the drive, is changed depending on the metallic coating that is applied to them. Now, you've got a very small area that the needle was basically swapping the magnetism on. If you're interested in learning more about how that functions, check out my video on hammer heat-assisted magnetic recording up over here. But to put it shortly, the needle is able to read and write to it by applying and swapping a magnetic polarity of a specific area, and then reading from that data later by reading the 1 or the 0, one polarity being a 0, one polarity being a 1. That data is then read as impulses, quite literally, that is oftentimes fed into a circuit board that has some kind of cache on it. That cache is generally flash-based, and it works very similarly to system RAM or video RAM in a graphics card or something like that. It's just a place for the data to go when it is being requested to help it be more quickly accessed by the rest of the system. Generally, they're anywhere from like 32 megabytes to 256 megabytes, sometimes even 512 megabytes. Oftentimes, you'll find bigger cache sizes on larger capacity drives, although that is not always the case. And you can also find multiple cache capacities on different sized, or on the same size drive. You could have an 8 terabyte drive, for example, with 128 megabytes of cache, or 256 megabytes of cache. But it is on a circuit board, and the data can be swapped there really quickly. Those hard drives are not as quick to read from or write to as the flash memory that's in there, so it's a good idea to be able to get things prepared ahead of time, essentially, and then that's generally flooded over into the system RAM, although it depends on where you're transferring the actual data to. Another thing that you'll see in hard drives sometimes are hybrid drives, or as they oftentimes are identified as SSHD, which is a solid state hybrid drive. And what these are, they're actually taking that kind of a cache architecture there that I just explained to a greater extent. So they actually install an SSD alongside the hard drive, a large portion of flash memory, generally somewhere between 8 and 128 gigabytes, although you don't generally see them quite that high. It's more commonly around like the 16 to 32 gigabyte range. And this allows the hard drive to dynamically adjust what data it thinks that you're going to need most, which is oftentimes software controlled, and it throws the data that it thinks you're going to need access to, most quickly onto the SSD portion of the drive. Now that's commonly going to be your OS, files that you maybe access every day, applications that you maybe boot up with and turn on every time you boot up, like maybe your web browser or something like that. A lot of that data is going to be stored there, as well as potentially data that you are currently trying to access. It tries to dump in as much as it can. Maybe you're playing a game and it knows that you're playing that game and it tries to move a portion of what's going to be needed next in the game over to there. Again, it's all software based though, so it really depends on what the developer decides to put in the SSD portion of the hard drives. So the actual data that's in there can vary greatly, but they do tend to boost speeds by quite a large amount. But they're starting to, in a way, go out thanks to actual SSD caches using Intel Optane memory, for example, which I'm going to be explaining in another video to you guys. But Intel Optane memory, they can use it actually as a hard drive boost or even an SSD boost because of how fast it is, but generally it's used for a hard drive boost. And those can give an even more significant performance improvement over having an onboard SSD on the hard drive, SSHD as they're commonly called. But anyway, in summary, hard drives have platters in them, typically made of glass or aluminum with a metallic coating that can have magnetism applied to a specific area on it so that you have zeros and ones or specific polarities. There's a motor that then spins that platter and a needle reads and writes to it. So it's actually fairly simple in some ways when you think about it compared to a lot of the other functions of a computer. So, that's the simple explanation right there, that little summary I gave you, but they actually are complicated when it comes to the end all, of course, and there's a lot of science along with chemistry and physics that go into it when it comes to the friction of the drives and how fast we can realistically spin them and stuff like that. So anyway, everybody, thank you for watching. Don't forget to like, subscribe, leave a comment, let us know how we're doing. Check out all the links in the description. We got links to our social media pages, so you can get a hold of us more directly. The comment section tends to get flooded a little bit, so it can be sometimes hard to sort through them all, although I try to get to them as quick as I can. And of course, we've got our links to our website there where there are news articles, and our forums are also down there, and our Patreon page if you're interested in giving us a monthly contribution to help out the channel. We really appreciate everybody that's been helping us out, and we really appreciate everybody that has helped us get to this 1,000 subscriber mark. We are incredibly grateful, and it's been a wonderful, wonderful experience, and we plan to keep going. Next time 2,000, next time 10,000, 100,000, we want to keep growing, so we're going to keep pushing for you guys, and thank you very much for watching.